Hi everybody. In this video we'll talk about functions, which is the last of the four really big foundational topics of a general programming course. So in any general programming course, the four really big foundational topics are if statements, lists, loops, and functions. So today we're doing the last of those four, or we're beginning the last of those four, which is not to say that we're anywhere close to being done with the material. Okay, there's a lot you can do with functions, and then once we're done with functions, we still need to do smaller, they're still important but not foundational topics like dictionaries, like arrays, things like this, before moving on to data analysis. So we still have lots to do, but in any general programming course, there are four really big, really foundational topics, and today we're starting the last of those four. So the goals of this video are to motivate the idea of a function, talk about why they're useful, give you a definition of a function, and then show you some basic Python examples of functions. So let's start by motivating why you might care about something like a function. So consider this problem. I ask you to write a program that lets two people play Scrabble. So if you don't know the basic rules of Scrabble, you should pause this video and go look them up. I don't have time to outline them here. This is a popular game though. I assume most of you at least know the basics of how a Scrabble game goes. So assuming you know the basic rules of that game, let's think about what kind of tasks go into building a program like this. All right, so what kind of things would you need to teach the computer how to do if you were to build this game? Well, there are lots and lots of such tasks. I have given you 7 of them here, but there are many more. First of all, you need a way to show a given player what letters they have, right? So I need to know what my 7 letters are on my little board. You need a way of letting the player place a word on the board. Once a word is on the board, you got to make sure that the placement is legal. So Scrabble has all sorts of rules about how you can place your letters. So for example, it has to be connected to what's previously on the board, right? You can't just put a word down anywhere you feel like. And at the spots where it's connected, it has to form words, So anyway, there are just rules about where you can place your letters. And of course, you have to place a word, right? So the computer is going to have to be able to check that the word is actually a word, right? It's not just nonsense. After a legal word has been legally played, you need to know the score of that word. Once the score of the word is known, you have to then update a running total of the player's overall amount of points. And after a word has been played, well, the player has played a certain amount of letters from their hand. Now you got to let them sort of reach into that bag of letters and refill. And there are other things, right? But at the very least, here are 7 tasks that you would have to figure out how to do if you were building a program to play Scrabble. The overall program can be built up from these discrete tasks, much like building a piece of furniture from IKEA, right? So you buy your desk or whatever, and you assemble it from its component pieces. So the program itself, you can think of as just consisting of all these little component pieces, all of these parts, that you shall assemble in a certain way to achieve your end being a Scrabble program. Okay, what functions do is they allow you to do this. So each of these discrete tasks, you can treat it like its own sort of sub-program, its own little sub-task. You can write a little program to do that. So write a little program, right, that checks that a string of English symbols is actually a word and not just nonsense. That's a task you can write. And, this task here doesn't have to take place in the context of a Scrabble game, right? There are lots of contexts in which you might care about whether something's actually a word or not, So anyway, each of these 7 tasks can be thought of as like its own little mini program. And then the Scrabble program is a way of combining all these in an appropriate way to create the end of Scrabble. Okay, so what functions allow you to do is they allow you to break a program down into its component parts in a really nice, organized, streamlined way. So yeah, as I said, functions allow us to write each of these tasks separately and then assemble the program from these pieces. Furthermore, once you've written a function for a given task, you don't need to rewrite the same code more than once. Okay, so what we're going to do is, throughout the game, there are many, many times you're going to have to calculate a person's score or, refill their hand or whatever, right? you wouldn't want to write that code over and over and over again every time you need that to happen, right? If you were to do that, the code would just like get super, super long. You'd have to be just obnoxiously copying and pasting things over and over and over again, right? But the idea of a function is, well, once you've written code to do this once, calculating a word score, then just like grab that code and use it, right? You don't need to rewrite the same code over and over again. So this is all kind of abstract, right? Because I haven't actually shown you what a function is yet, right? But before I do, the reason you'll use them, if you've accepted the motivation I've given you so far, is first of all for organizational purposes. If you're going to write a sophisticated program with lots of code, it is helpful to take the larger task, the larger program, and break it into a bunch of smaller pieces, each of which is done by a function. This makes the code more readable. So if you were to hand this code off to a fellow programmer, or like, you know, if you were to leave your company, right, and your code is still there and somebody else has to come in and deal with it, it's much easier for another human to come in and see what was going on. It makes the code much easier to debug. So if there are issues, right, if you've broken the program down into smaller parts, you can just sort of investigate the smaller parts on their own and see if there are any issues there. If for whatever reason you want to change your program to do something else, right, for a different purpose, functions make it much easier. So just as an example here, with Scrabble, your hand consists of 7 letters. Well, 7 is kind of arbitrary. You could imagine a Scrabble game where you're allowed to have 8 letters, right? So suppose you wrote your Scrabble program and then I came along and said, oh, sorry, I really wanted to play with 8 letters, not 7. If you've built your program from functions, right, think about these 7 tasks. Does this task care that there are 8 rather than 7 letters? No. You wouldn't have to modify this at all. Does this task here care that you have 7 versus 8 letters? Not really, right? I mean, you're just putting stuff on a board. Placement being legal doesn't care about how long the word is, right? Whether the word is actually a word doesn't care. Calculating score of something doesn't care, right? Blah, blah, blah. It seems like the only task really that cares about how many letters you're allowed to have is this one. Okay, when it comes time to refill your hand, you know, if you've played 4 letters, you get 4 more. I said that wrong. But anyway, you can refill your hand up to 8 letters, right? Rather than refilling up to 7 letters, is all I'm saying. So anyway, if you've built your program from these component pieces, many of these wouldn't have to be changed at all to make that tweak to the game that I described, right? You'd really just have to sort of think about this one of what I've listed here. Okay, as I mentioned before, functions make things reusable. Once you write a function for a given task, you can just reuse that code as many times as you want to without having to rewrite. Abstraction. If you want to use a function, you actually don't need to know how it works. Okay, so once a function has been written by you or someone else, right, all you need to know is how to grab it and use it for your own purposes. So if you think about what this is saying, we've seen this play out a number of times, but probably the most salient example is the random choice function we've been using, right? This function, we didn't call it that necessarily, but you know, you feed in like the numbers 1 and 6, right? You ask that rand_int function to choose a random number for you between 1 and 6. That's a function somebody else built, you know, and we actually have no idea how it works, right? We haven't sort of opened the hood to see. All we know is that it's working for that purpose, right? The purpose of choosing a random number in a given range. So we just grab it and we use it for that. And we actually don't need to know how it works, really. I mean, it would be nice to know, I suppose, but we don't need to know for our purposes, right? And there are other uses of functions, but these are the big ones. Finally, real programming. Okay, what does real programming mean? Like, not just writing a little like prime number tester or whatever, like calculating your course grade or something. Programming in the real world to accomplish real tasks, right? It just is impossible without functions. So since you don't even know what a function is right now necessarily, you have to take this on faith, but I'm just asserting this to you, right? As somebody who has done real programming, okay, and knows programmers, right? Just like loops, just like ifs, okay, you cannot program in the real world without functions. Okay, so now let's actually talk about what a function is. So again, this is still kind of abstract. It becomes much clearer when we have some examples in a second, but here you go. A function is a named group of code, so it has a name, And the reason it has a name is so you can grab it, right? So the computer knows what kind of code you're trying to grab. And it performs a specific task. A function comes with a list of parameters, or if you like, arguments or inputs, whichever language you like. The function takes in its parameters and performs its specific task with them. Okay, so more generally, a function is just sort of an abstract machine that's handed some stuff and it's told to do a job with that stuff. So then the function does its job, right? So here's an example. This is an example from a Algebra 1 class or something. F of x equals x plus 1. Okay, this is notation you would have seen in any sort of high school math class, right? Function notation. What's going on here, right? If you had to explain in plain English what is this thing and what is happening here, the English is this. Okay, this is a function. It takes as input a number. I'm going to feed a number into it, and I'm denoting that number by x, but I could have denoted it with anything. I could have put a smiley face there and then a smiley face there. What the function does is it calculates one more than x. So if you feed in a 5, it gives you a 6 back, right? So you feed in a number and the function returns to you, sort of on a platter, right? It does a calculation for you, one more than what you gave it. And the function's name is f, right? So in English, right, you can say, I built a function. The function accepts as input a number, and it gives you back one more than that number. And I've named the function f. So if you, other user, would like to use this function, go ahead and call it f, right? So this notation here is nice because it encapsulates all that English, right? It's a pain to say all that English every time. But that's what's happening here, right? There's a name, f, and here's sort of a formula for what the function does. Here's another example, g, now a different name because it's a different function. It is going to accept two numbers as input, which I'll separate as commas. Two numbers as input, I'm calling them x and y, and it's going to calculate their product. So if you feed in a 2 and you feed in a 3, the function calculates 2 times 3. It will calculate 6. Okay, so again, all the English there of oh, this function is called g, so if you want to use it, be sure to call it g, 2 inputs, blah, blah, right? All that English is encapsulated by this notation. Here's another example, right? I can input 3 numbers and sum them and divide by 3. So this is a function called h that accepts as input 3 numbers and calculates their average. Okay, so again, a function is a named group of code, right? Each of these things has names, f, g, h, performs a specific task. These tasks right here, right, are not particularly interesting, but we got to start somewhere, right? This task is to add 1 to the input, and there's only a single input. This task is to multiply the 2 inputs. So it comes with a list of inputs. That list of inputs can be as long as you want it to be. Okay, depending on what you want your function to do, you might need to hand it a billion things. Who knows? Okay, this function, right, its task is to accept 3 numbers and average them. So each of these functions has a name, a list of inputs, and a job it performs given those inputs. So the question is, if you want these functions to work in Python, how do you build these things in Python? And the answer is like this. If you want to build f, in Python you say def, that is short for define. So define, name function here, f. And so again, you can call these basically whatever you want. I decided to call it f because that's sort of standard math notation. And then you put your input name in here. And then you say what's called return here. So return means give me back, right? Calculate for me x plus 1. So Python will now know, oh, there's a function named f. There's one input, which the programmer is calling x for right now. And what I need to do as Python, as the computer, is do 1 more than x and give that back. Return that. So you feed in a 3, what comes back at you is a 4. With the g function, same idea. Now you just have to tell the computer there are 2 inputs, right? Which you can call whatever you want, but I've called x and y. Return xy. h, x, y, z. Return x plus y plus z over 3. So let's actually play with these in the compiler itself. Okay, let me make this text bigger here. So notice I've already put the functions in here. All right, so I've already got my f in here, my g in here. Make this big enough so we can all see it. And my h is already in there. Okay, so this is just from the slide, right? Define f of x colon and then return x plus 1. One thing I forgot to mention, but you can see from the slides and this, when you're inside of a function, it's like being like inside of a loop or inside of an if. You have to indent things. So if you put the return right here or something, the computer's going to yell at you when you try to run things. Okay, so in Python, you put your functions at the top of your code, and then when you're done with your functions, you come down here at the bottom and start doing things with them. So like, let's let x be 2, for example, and I'm going to let a be, just give me some room here, I'm going to let a be 4, okay? Sorry, I'm going to let a be f of x. Okay, so x is 2. I'm going to feed that x into the function f, and I'm going to put the result inside of a, and I'm going to print a. Let's see what this does. It prints the number 3, okay? As it should, right? So what's happened here? X has value 2. I fed x into the function, so this x up here takes on value 2, the same one from down here. The function gives you back 2 plus 1, so it gives you back a 3. So now a has value 3. So when you print a, you get a 3. So that's how a function works. That's how you can use it. So up here, you've just sort of like put code up here that you can reach up and grab. Okay, so what's literally happening in the code here, when the compiler reaches this line of code, f of x, it says, oh, f, I've seen that before, right, because it's up here. I've seen that before, so what I'm going to do is leap. I jump up here, I feed the x value in here, 2. I do whatever it is I was told to do. And then I come back down here and just continue. Okay, so the computer is jumping around. It's worth noting also, by the way, that this x here is just a generic name. It's just a generic name for an input. So I don't need to have the names match. So what if I do like a c right here? C is 2. Feed c into this function. Let's run this code and see what happens. Again, a becomes 3. All right, so what's happening here is c is 2. So now you're feeding in a 2 basically, right? The computer knows the value of c is 2. So then that value of 2 is given to this x. Right, so again, this x is just some generic stand-in for whatever you're going to feed in, and then you're going to add 1 to it. So you don't have to worry about like names matching with these parameter names up here. Your names, when you actually use them down here, can be whatever. Okay, so let's have c equals 2, d equals 7, and let's let a be g of cd. So g takes 2 inputs, and it returns their product. So let's run and see. Yes, okay, so can you see what I did wrong? This is so obnoxious, right? We've discussed this before. Python insists on a multiplication symbol there. Okay. So with that error corrected, notice it gives me 14, right? 2 times 7 is 14. So I fed 2 and 7 in, right? X becomes 2, Y becomes 7, right? And then it gave me a 14 back, which it printed. Finally, let me do like CDE equals 7 also or something, right? And let's feed in H. Now, H requires 3 inputs, so I got to feed 3 of them in there. And it gives me back the average of 5.3333. That's now the value of A, which it tells us. Okay, so that's how you define a function, and that's how you actually use them. So these up here, again, are just sort of separate tasks, separate like chunks of code or separate calculations, whatever, that you can reach up and grab whenever you feel like. So if at any point in your code down here, you need to average 3 numbers, you can feed those 3 numbers into H, and it'll give you the average back. Okay, one last little thing to mention here is that the order in which you hand parameters in matters. So let me change this to an x minus y here. And let's let A be G, C, D. So I feed in 2 and 7 in that order. 2 minus 7 is -5. When I run the code, I get a -5. Okay, if I feed in DC, right, Well, then up here, the value of d is passed to x, the value of c is passed to y, so now I get a 5. Okay, so you have to be careful if there are multiple inputs that you list them in the order you really mean them to, right? So here, whatever's passed first comes first in the subtraction, and whatever's passed second comes second. Okay, so these are very basic, very low-level functions. These are functions you would never build in practice probably, right? Because who cares about such small little tasks? But again, we have to start somewhere. So starting next time and the time after, we'll build more useful functions. So let me conclude this video by saying that the functions we've dealt with so far all had numeric inputs, right? We fed in a 5 and got a 6 back. We fed in 2, 7, got a 14 back, whatever. And sorry, there should be an asterisk right there, right? But anyway, you can feed in whatever you want to a function. You don't have to feed in numbers. So here's a function that accepts a string as input. Call this function greeting, right? And you can feed in a name. And it says, well, hello. And then it says your name. Right, so this is a function that just exists to greet you. So if you want to reach up and grab this, you do greeting and then feed in the name. If you have a list going and you want to calculate its sum, we've already talked about how you calculate sums of numbers in lists, but notice you can feed in a list into a function if you feel like. So numbers here is a list. And you calculate its sum the way we've done before. Sum is 0, and then just traverse your way through the list of numbers and just add each number one at a time and then give the sum back. Okay, so you don't have to feed in numbers all the time. You can feed in a string, you can feed in a list, whatever. You can pretty much feed into a function whatever you want as an input. Okay, so that concludes this first video on functions. Hopefully you are comfortable with these kinds of examples. You can build these on your own and use them the way that we had in the compiler a second ago.